Welcome back. All right, so we're going to do scientific notation for those of you that have taken the quiz, taken the quiz, and you have 100% on this one. And you need something to do. All right. Well, our next subject and last one in this little series, this concept of exponents and powers of 10 is scientific notation. This is the actual reason that you did the first assignment, because scientific, use very large and very small numbers. When they look out into space, the numbers are very big. When they look into a microscope, the numbers are very small. And so instead of writing, 100 gajillion, like 1 0 0 0 0 0 0, they don't write all the zeros. They use scientific notation, which is that times 10. So scientific notation is it's a base, I'm going to call it a base number times 10 to an exponent. Okay, but the number is always like it has a ones place, and then it can have only a ones place. So if there's a number with a tens place or hundreds place, it's not in scientific notation. So some examples would be 2.3 times 10 to the 8th. That's an example. 3.1 times 10 to the second. That's an example. 10.23 times 10 to the 7th. This is not an example because it's got a tens place. Also 207.1 times 10 to the 5th. That is not an example because it has a hundreds place and a tens place. Yeah, bad examples. Okay, so we're going to write this in scientific notation. 427,000. We know that 1,000 means 3 zeros. And so we want to take this number. If we put a decimal point, it would be right there at the end of the number. And we want to put that number so that it only has a ones place. So I'm going to move it how many times? 1, 2, 3, 4, 5 times. That was 5 times. Okay, so then there's going to be 4.27. There's only a 2 and a 7. The zeros after the 2 and 7, I don't have to write. And since I had to move it 5 times, it's going to be 4.27 times 10 to the 5th. So let's write that. 4.27 times 10 to the 5th. All right. So if we're not in scientific notation, the normal way you write numbers that you're used to is called standard form. And so that's with all the zeros. Oh my goodness. Hold on, let me turn the lights back on. Okay. So the 9 means that we're going to move 9 decimal moves to the right. All right, to get this thing out of standard form and into get this thing out of scientific notation, we need to move our decimal point to the right. So I'm going to move it 9 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to put it right there. And for every empty space, what do you think I'm going to put? I am going to put a 0. And that's it. Then I'm done. So how many zeros is that? 3, 8, 6, 8, 1, 2, 3, 4, 5, 6. I'm counting 6 zeros here. There you go. All right. Express this number in scientific notation. Okay, so now we're just going to do that same process backwards. Still, we want to know how many times do I have to move the decimal to get it into the form that I want. So the decimal point, if we wrote one, would be right here. And we want to put it right here so that there's only one space. 1, 2, 3, 4, 5, 6, 7. I'm counting 7 spaces. So I have to write that many numbers because that's the last non-zero number. But I had to move it 7. So it's times 10 to the 7. 5.301 times 10 to the 7. All right. All right, let's do this. Thousandths. So of course this is a small number. The thousandths place is the tenths. Okay, tenths, hundredths, thousands. That's a third. Third decimal point. So that number is this. And if we want to write in scientific notation, we need a ones place, right? So we need to move it one space that way. But notice this is the opposite way that we've done in the previous examples. That means it's a negative exponent. So this is going to be 7.63 times 10 to the negative first, because number is less than 1. Anytime the number is less than 1, we have a negative exponent. It's not a negative number, it's just less than 1. That's how that goes. So it's going to be 7.63 times 10 to the negative first. All right. Here's another one that's less than 1, and I know because it has a negative exponent. So in that case, 2, 3, 5, and it's times 10 to the negative 4. So if I want to put this in standard form, I don't want to go this way because that would make a number bigger than 1. I want to go to the left. So I'm going to go 1, 2, 3, 4 for my decimal point. But just like the numbers that are bigger than 1, what do I put in the empty spaces? 0. All right, and then we have our number in standard form. 0.0008235. Okay. Hopefully it isn't too bad. Express this number in scientific notation. This number is less than 1. I know because it has a 0 in the ones place. So we want a negative exponent. So I know the negative exponent because number is less than. Okay, so in order to get it into scientific notation, I need to have a ones place. So that means I need to move that decimal point 1 time, which means my exponent is going to be negative 1 because I had to move it 1 time. $31 billion? All right, I'll do 31 billion. So billion means 9 zeros. 9 zeros. I know that because I want to be a billionaire. I want to be a billionaire. Da, 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 da. Okay. So there we go. There's the number in standard form. Now I wrote it like that because I was just wondering to myself, how many decimal points do I have to move? So now I'm gonna do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 moves, which means my exponent is 10, And my number is 3.1. 3.1 times 10 to the 10. 3.1 times 10 to the 10. There we go. If I got 100, so can you. And we can write the success criteria after we both have 100. That'll be great. Okay? So good luck hosting the organizer. If you need any help, raise your hand. Whatever you need to do.